So today we are going to discuss an interesting topic on free energy devices. Okay, so so what do you mean by free energy, right? When you get energy that you don't pay for, it is called free energy. For example, you have an electricity line which is from solar panel. Uh, that is not exactly a free energy because you have paid for the panels and it has a lifetime for it. But if there is a device which gives more output than the input it receives, then the extra energy is practically free energy because we are not paying for it. So that is what I mean by free energy. So any device which does this, giving more output power and energy than what is being fed into the device, that is called a free energy device. Yes, such devices do exist, and in fact, you can build your own. Okay, and I would like to clarify that it is not the same as perpetual motion machines. We'll just call it PMM, right? Uh, PMMs may exist. It may be possible to make one, but it is not relevant for the discussion here because we are not interested to have a theoretical discussion about whether perpetual motion machines can be built or not. We are more interested in using free energy in our day-to-day life. So there is a term called coefficient of performance, COP. It refers to how much energy comes out in relation to the input. So if you say COP 5, it really means that the free energy device is giving out 5 times more energy than what it is receiving. So any free energy device must have COP of greater than 1, or it is also called over unity. So that is a free energy device. Okay. So now immediately the next question people ask is, what about the law of conservation of energy? You know, the very first law of thermodynamics. Energy can neither be created nor destroyed. Okay. So the main thing is there is no such law, which is verifiably true. So if you look for proof for this law, uh, so there is no proof that I could find. Okay, but there are a lot of contradictions that exist, which is like disproof for the law of conservation of energy. Okay, so a very straightforward, what do you say, case is electricity, flow of electricity. But when you talk about proof of law of conservation of energy, they always talk about falling masses and what do you say, you lift up your weight or, to certain height and drop it, and kinetic energy converting to so-called what do you say, latent or static energy and so on and so forth. There are a lot of mathematical talks and stuff like that. But there is no, these are all evidences. Okay, so when there is a energy loss, when you do some work with a device, that is not proof of law of conservation of energy, but it is an evidence. Proof really means there is no counter argument possible, or there are no practical cases that what do you say, contradicts the law. But if you look at electricity transmission across the world, electricity transmission is almost instantaneous. Okay, over any distance. That is what we practically observe in this world. See, for example, if you put out a electrical line which is like 300,000 kilometers long, okay, and then you connect a light bulb at the end of it and a battery at the other end. So, since no speed is greater than the speed of light, which is traveling at 300,000 kilometers per second, ideally, you will expect the electricity to become available and light up the light bulb after 1 second after you throw the switch on. Okay, but when in practice, it lights up instantaneously. As soon as you put the switch on, instantly the light comes on. This has been the observation, okay, which directly contradicts the law of conservation of energy, and nobody really cares because it is not there in your textbooks. But in practice, this is what engineers observe. Now, this fact has become so popular and so widely known that even Veritaserum decided to put out a video on it. And this video has hit 15 million views. And still, the textbooks are giving you false information about the propagation of electricity. So, if electricity is getting transmitted instantaneously, it should take infinite energy to do it because, as per the theory of relativity and all popular quantum mechanics, or whatever theory you talk about, nothing can travel faster than light because it takes infinite energy to push through the threshold of uh, speed of light. That is the theory. But that theory is probably wrong. It so if that is wrong, then there is no real proof possible for law of conservation of energy either, because they are all interlinked. So this is why I am saying that the law of conservation of energy has no proof till now. Anyway, the real thing is we don't care about law, whether the law of conservation of energy is true or not. We are more interested in actually not paying our electricity bill. That is the bottom line. So if you want to have a theoretical discussion about conservation of energy, we can do that outside of this presentation. But for this presentation, I am going to focus more on free energy that you can practically use. Okay. And especially I'm going to focus on gravity-based free energy devices. So anyway, the real bottom line is we don't really understand what energy means because there are so many issues that contradict the mainstream view of what energy is, and the very unit of joule, the definition of joule, the energy measurement unit, that itself is contradictory to itself. So now getting into the free energy devices, there are so many classes of free energy devices. Okay, so Patrick J. Kelly has made a brilliant book, which is a summary of most of the devices known till today. And it is there available in freeenergyinfo.tux.nl. So you can download these and browse through that. And there are so many categories. There are hundreds of devices he has described in his book. So you have magnet-based devices. These are really dangerous stuff. And Tesla coil induction devices, gravity-based devices. And we will be talking more on this in this presentation because they are easy to build. Pulsed systems or battery charging systems, which take the energy from the environment. Aerial systems where you put up conducting cables at a certain height from the earth, and it leverages the potential difference between earth and the atmosphere, and through that we can extract the free energy. Okay, and then the fuel-less motors. So some of these motors power themselves up through some kind of a loop, which works with the magnets, but there is no loss of either magnetism or the output. It's very strange. And there are many of these described in Kelly's book. You can look at it and you can build one if you have the expertise. And so on and so forth. There are so many other categories. Okay. So now moving on, let us look at, okay, so just a word of caution on magnet free energy devices, because I started out playing with these magnets, neodymium magnets, to build a magnetic gun. So you arrange the neodymium magnets in certain way and put one magnet in the middle, and then that magnet gets accelerated like a bullet, and you can actually shoot it at enormous speed. Okay, so as I was building it, I used the strongest possible glue I could find, But then, as I kept adding more and more magnets, it became stronger and stronger. The overall magnetic field became so strong that when I put the last magnet in, all the magnets got ripped apart from the underlying platform, and then it almost broke my fingers. So this was the last experiment I tried with magnets, and then I decided, okay, no more trying with the magnets stuff, because it is just too dangerous to do it at home. You have to do it in a safe industrial setting. Okay, and after that I saw what I can try my hands on, and this Joule thief circuit popped up. It is so easy to make. You have only one transistor and a battery, and through that battery you can charge a completely depleted battery. So you can see one battery over here on the left, and one battery on the right. The one on the right is depleted fully. So I was trying to charge this one, this battery with the power from this battery. But the thing is, as the energy flows to the coil in the here, there is some kind of a pulsing that gets generated because of the transistor. And those pulses somehow draw energy from the environment and charge this battery without any loss of power from this particular battery. So this circuit actually worked. I could hear the transistor ringing with pulsations. So I tried measuring the current coming out, and then the spike is so strong that it blew the multimeter spark. I mean this one fuse. So I'm still waiting for the fuse, by the way. So and at the end of it, the other battery charged up all the way to 1.2 volts from zero point 0.5 or zero point 0.6 volt. So this circuit actually works. So if you want to try it out, you can try it out. It is there in Kelly's book. It's very easy to make if you are interested in electronic stuff. So this is what got me totally interested. That okay, there is some possibility of free energy happening. Okay, so after that, my interest kind of switched over to gravity-powered free energy devices, because they looked so easy to make and very rugged, very robust, and they have very high coefficient of performance efficiency. Many of these devices are like greater than 10. So if you give 1 joule of energy input, the output is like 10 joules coming out of the device. So, and also I could find that there are many successful implementations of these gravity powered energy devices exist. Okay, so there is no need to reinvent the wheel. So, I mean, to say. The pull of it's a combination of inertia, moment. I mean, the inertia and the gravity and the circular motions that somehow together gets converted to usable energy. And as I was saying, the circular motions produce a lot of centrifugal forces that gets added up to the output. So to tell you, I mean, to just give you an example of this gravity powered device, here is a pendulum based device. It is called Milkovich pendulum. Very simple case. This is a fulcrum, and there is equal weight between this side and that side. On one side, it is just a weight. On the other side, some of the weight are made into a pendulum. Okay, so this weight is cut out and then made into a small pendulum as 4 shown here. Okay, so when the pendulum moves inside like this, when it is moving inside, what happens is the overall weight on this side becomes less. Okay, so this tends to move up because this is less in weight and this becomes more in weight. And then this goes down and hits the anvil over here. And then this moves up. And as the pendulum swings to this side, the weight on this side beyond this fulcrum increases. Okay, so the whole thing starts coming down and then this side starts going up. Okay, so as the pendulum swings, back and forth here, this one keeps on striking the anvil. Okay, so the interesting part is the force with which this strikes the anvil is in proportion to the weights involved. For example, this can be 100 kgs and this can be 100 kgs and this can be just a 10 kg pendulum. As this one strikes one, it will strike with the force and weight of 100 kgs. Whereas the energy required to push the pendulum horizontally over here, it may be just very minimal, maybe 2 kg, 3 kg push should be sufficient to push this 10 kg weight around in a pendulum motion. Okay, so this is I mean, I could not find any counter argument to this design. It's amazing. Okay, if this one works, I could actually make it at home and then try it out, right? And even Kelly describes a feedback mechanism. So you just put a balanced rod like this, which is pivoted here. And as the pendulum swings down, it will come and hit this also. And then this will come and hit, I mean, it will go down like this and it will in turn push the pendulum out. So this will keep the pendulum swinging up and down, up and down, up and down. And only a small portion of the energy is taken out of this downward movement of the pendulum, main pendulum. So this way it should be easy to sustain this energy. Okay, so I mean, we should be able to keep it going forever practically. Okay, so here is a battery charging system somebody has put up as a demonstration. You can, this is a, what do you say, the battery which you can pump with your hand to power it up. Okay, so on this side is a weight pendulum which he can swing by hand. Okay, I'll just show you this video here. Let me see.
Irgendwo in Serbien gekauft. Und ich sage vor dem Mann, viel und diese Lampe ist schon 6 Jahre alt, also
so
der Akku ist schon mehr als in Ich muss ein wenig first, aber ihr seht schon, es fängt an zu leuchten. Und es ist jetzt das einfachste Modell, was man machen kann. Ich könnte ebenso oben auch noch eine Dynamo-Taschenlampe anbringen, weil die Aufwärtsbewegung, die wird jetzt überhaupt.
So the amount of energy required to push it is quite high. Okay, so because you can, it requires strength in your hands to actually push it. Here he is demonstrating that. It is not easy. But he can move this up and down with just a small finger because it is so easy to move. Okay, with that kind of a very small input, you can actually charge and keep pumping the flashlight at the other end. Okay, so he was, this is the way he was demonstrating it. I hope you got the idea. Okay, so let me close this and go back. Okay, so in a practical sense, even people have built water pumps with this kind of pendulum motions. So you can watch this YouTube video. I will upload this presentation later on. You can download it and go to these videos. Let me show you that water pump, right? Okay, here you can see the water pump operating. See that this water pump takes a lot of energy to actually operate. If you want to really do it by hand, you have to put your entire weight on the handle. That is when the water comes out. But as you can see here, He is just swinging the weight back and forth, back and forth. That is all the input he is giving, which is very easy to do. Okay, but it results on the other side pumping the water out, which takes a lot more energy than what he is giving with his one finger over here. Okay, so this is quite incredible, right? You can clearly see the demonstration of multiple times the energy coming into the system um, uh, and doing useful work on the other side. Okay, so I mean, feel free to watch this video. I mean, I got my mind blown with this one. It's amazing. So it is practically implemented, and there are so many other devices which are there, right? So I would like to, I mean, these kind of devices were built even very old times, even 1950s devices exist. There was a video on that one. Okay, looks like I have not copied it over. All right, no issue. So you can check that out. And here is a very simple demonstration of how you can convert that into a flywheel motion. Okay, the pendulum motion to flywheel motion. This is a nicely done demonstration. So you can see that is giving a very simple push with his fingers. And these weights are heavy weights. Okay, it's balanced. You can see the weight over here, and that is the same as this weight over here, the pendulum's weight. So as he keeps pushing, the flywheel keeps rotating, and you can extract useful energy out of this. You can connect a motor, or you can connect a generator and take power out of it. And that power will be proportionate to the swinging weights, not proportionate to the very, very small energy he is giving us input over here. Okay, this is again a very clear demonstration of very small input converted to quite a larger output, which may be usable. Okay, he is demonstrating it by, okay, you can push it either up and down, or you can push this swing across, like back and forth. So both motions are useful. You can generate it in both ways. Okay, so this is what the power of the pendulum, gravity based pendulum designs are. They're really good. And okay, so here is an industrial scale design. Okay, so it's again massive power, uh, amount of power. Okay, so let me show you the video. So he's here. Let me stop here. You can see that there is a heavy weight on this side, and there is a heavy weight on the other side, and it is mounted on a bar, and there is a fulcrum over here. That's it. There's a very simple, what do you say, balance. Okay, now you can see that this man is pushing this. This thing is over a ton or more. I think it's 1.5 tons, I think. And that is 1.5 tons. So you can see that the other one is coming down with a massive amount of force on that side. Okay. So and here is even better demonstration. Okay, so here you can see the same thing, except that there is this weight has a feedback path which you can push with this device over here. So let me show you that.
Hi.
Okay, so this man is pushing that weight, and you can see that this one, it's a air pump basically, and here's a switch. So once the weight hits the switch, this is giving a feedback. Okay, and you can see that on the other side they are harvesting this energy by converting the up and down motion into one-way rotation over here. And this energy is being used to charge this gas chamber, gas cylinder, which in turn powers this device to push it. Okay, this particular device ran for about a year without any assistance, and it was generating about 20, I think 25 kilowatt of power continuously. Okay, so you can watch the video on YouTube. I'm not going to spend time on that right now. So, and even commercial implementations also exist of this particular device. Okay, so you can let us see where that thing is. I hope I have copied it. This. Okay, looks like I have not copied that. Okay, leave it. Yeah, you can, I have given the link. You can see that this company actually has built a massive pendulum. We were swinging back and forth, and it was generating a lot of energy. I don't know whether this company exists now or not. You can check. It's called Gravitational Energy Corporation. Okay. So now, if you can convert the swinging pendulum into a full rotational motion, right? For example, here is a cycle wheel, and you put weight on the rim. Okay, so it becomes like a pendulum. You can move it like a pendulum back and forth, and see how much energy it generates if we can rotate it as a full circle. Okay, so this is again another amazing demonstration. Okay, so this is by McNamara. Here is his daughter standing here, and here is a fulcrum on which the whole thing is mounted. So her weight on one side and this bicycle weight on the other side with this rotation thing attached. Okay, now he is going to spin the wheel.
And let's get this going here.
Okay, he is spinning the wheel. Now you can see that it is lifting her whole weight off, and the input he is giving on this side is just with one finger. Okay, you can see that he is just rotating with one finger, and it is sustaining continuously by lifting her up and down. She must be at least 25-30 kg minimum, and you can see that the system is throwing her like a doll up and down.
Okay, guys, that was
continuously. Okay, unfortunately, he didn't upload a whole lot more on this one, but McNamara has many nice videos demonstrating this over unity. You can go and watch his channel. This is again, it's amazing demonstration of over unity and how very small input gets converted into a massive amount of output. Okay, so the same concept of rotating pendulums at the full speed. People have made really nice designs, and I particularly like this bouncer design, which is really well made. So this is a bouncer running. The design is simple. You have a motor here, and this motor drives a pendulum to swing upside down. And the rotating weight is going to lift the entire platform up and down. And the energy is extracted by connecting the platform into a flywheel, into horizontal flywheel. And you can take this, you can connect this part into a generator and take useful energy. So appropriate springs are mounted to show the what do you say for smooth operation. Not only that, you can connect this one into a multi-stage generator, and you can add more flywheels for better stability and smoothness of operation, and you can extract more and more energy through this uh, rod over here. Okay, so this is again a really cool design, and people have made these designs. You can watch the video. Now, it is also very simple to make. I mean, very straightforward and simple to make. Okay, so here this video was shared to me by Kevin. He is in British Columbia, and this is pretty cool. I mean, same concept, but with a very simple bicycle uh, demo. Okay, so you can see that this is a bicycle wheel,
Okay, this is for
and
you,
this is a
Petra.
motor.
Actually,
So I'm going
some
to
create
skip
somewhere. So for
to
months and
the
months I'm wearing.
demo.
I'll test it, but
Yeah,
I'm not
so
going to
he
do
is
that right
connecting
now.
a simple
So this
12-volt
motor
motor
here
with a
is
drained battery.
1/10
So you
of an
can
amp,
actually stop this
12
wheel
volt
with a single
DC
finger
current,
because there is
and the
nothing
drive
much.
function of this wheel,
You can see
you can
that he
stop
is
with a
stopping the
finger,
whole
so you
thing
can
with a
see
single
those.
finger. The input is very, very weak actually.
And this is why I haven't been using this as demo or making videos, is because none of this was set up for any long term. It was just built to test a very minor function. So it is what it is, as I said. It is what it is. So there you can see the wheel, the function of the wheel. That's the drive function, 1/10 of an amp. There's not enough power even to hurt my finger here. I can stop the entire drive function with one finger. Here's the important part, is I put this here and get it going.
Look at that. So that very
I can't
small
stop this end
energy
of it.
is just throwing the entire
This end
platform up
here
and
just
down.
has so
If
much
he is
power
not
when I
holding
do
it
that
with his
that
hands, this would have been thrown out actually. Massive amount of output.
the faster it
You
goes,
can see that.
of course, the easier it is to run, the less power it goes. So
Yeah, he is
this
not able to
little unit
sustain it
needs to
beyond
be
a point.
bolted down. It's just a
Okay.
little portable piece of junk. But
So
the increase
that is what it is. Okay. These are very easy to make. In fact, he has shared his design, and this is the flywheel with a 10 kg weight attached to this fulcrum, and the other end is connected to a flywheel over here, which is 100 kg flywheel, and it is also connected to a generator, and you can connect it to multiple generators, and you can simply run this small motor with a 12 volt motor, and it can rotate this 10 kg weight. Okay, so his calculation says that at 6000 rpm a 10 kg displacement weight can actually generate about 120 horsepower, which is mind-bogglingly high. Okay, so you can go through his calculation and see, but I'm not interested in the calculation. I'm more interested in the useful energy coming out. Okay, so I have created the same magic. He calls this magic, and he has been banned by most of the social media platforms, including LinkedIn. Okay, he's gone from everywhere. And I recreated his design in Tinkercad. You can click this link and you can view it in full 3D. It's very easy to make actually. I just added one more, this one, and kind of added some more innovation in taking the energy out in a more efficient, more effective way. Okay, so this my design is free for you to view and download. You can download it to make it, run it, and do whatever you want with it. Okay, here is another design which is I think we can extract more energy out of this design. This pendulum is now mounted in a two-axial axis system. So as the pendulum rotates like this, the up and down motion energy is captured by this rods over here, which convert that into rotational energy, and that goes to the output generator. And as the pendulum swings this way, it is going back and forth. That energy is converted by this mechanism over here, and then again it is all consolidated and fed into this generator. So this is much more efficient in extracting the last bit of energy out of coming out of the pendulum's motion. Okay, you can click on this link, and this is my own design, and you can make it. If you have a basic hardware skills, or you know a workshop, you can make these designs very easy to make. Okay, so even more efficient than pendulum-based designs is the rotating weights design. Okay, so here you can see that this is a heavy weight which is mounted on a fulcrum like this, and this is a universal joint, by the way, and there is a rod over here. Okay, when you rotate this rod, what happens is you will shift the center of gravity for this wheel, and then the wheel will start falling towards that rotational direction, and then you don't stop the rotation, right? You continue the shifting of the center of gravity, so this wheel starts continuously falling towards that direction, and it results in a circular motion of this heavy weight. Okay, so for a very small energy input, which is like shifting of the center of gravity here, the whole weight is going to rotate like this, and then you can extract that energy out by connecting this output through a chain mechanism to a generator, and part of that energy you can feed it back to the input motor, which drives this shifting of the center of gravity. Okay, so that is what this design is, and you can go look it up from the PJK's book. This again very efficient design. Is a really cool design which anyone can implement easily, and very old implementations exist. So this particular one is from 1950s. Video later you can see. So essentially the point is people have made large scale versions of this shifting weight design even in 1950s, and Skinner has made it in 1939. There is a video that is available, and I have also implemented it locally here. The input motor over here is 0.5 HP, which is stepped down, and then I have 40 kgs of weight here rotating. Okay, so you can really stop this input with your fingers. Just to hold it, the whole thing stops. But the output coming out of this wheel, the flywheel over here, so massive that you can't stop it with both your hands. Even if you throw your weight at it, you cannot stop. So let me show you that video. Yes. Where is that? Yeah. So this is my prototype. You can see that, okay, this motor drives the input shaft, and it is shifting the center of gravity. It is not exactly perfectly made, but it demonstrates the concept. And the weights are continuously falls towards that side, and that weight is extracted and taken out over here through this flywheel. So before I could actually get the generator connected to this one, there are so many practical issues, and the person doing the design, he had to shut his workshop thanks to COVID, and that was the end of it. So right now this is sitting somewhere in another workshop, just sleeping. Okay. So, but you can go ahead and make your own. I'm going to continue somewhere. Let us see whether I can finish this one. And here is Skinner's machine. Okay, he worked on it for 5 generations, meaning, I mean, he claims that this is a 5th generation design he was demonstrating. And he was running his entire lathe with just this machine. And he was climbing a coefficient of performance of greater than 16. And what he was using is much more than 16 actually. So these are all shifting weight based design. It's amazing stuff. So I have made a video of this one, and there are so many successful model implementations that exist. And you can, this is the, what do you say, this is the best one model I could find. It implements all the features of the advanced Skinner's generator design. Okay, so the gimbal is here, the leading weight, the following weight, and the energy extraction at the bottom, and just one motor driving the whole thing. And I mean, this is really well-made design. Somebody has put in a lot of money on it. You can view this one, and there are a lot of walkthrough videos available. You can try these things. I have also made this design in Tinkercad. And Murakami, there is another channel called Murakami. He has given a brilliant idea on how to simplify Skinner's input mechanism over here to create the elliptical movement by using a bicycle kind of a design. So I have kind of implemented it here in this design. You can go ahead and download this Tinkercad model and what do you say, recreate it in AutoCAD and actually implement it. Okay, so that is about what is a pendulum-based designs. So let us quickly look at the Donny-Watts generator, because this also it is not exactly gravity-based, but more of centrifugal force-based. So the most interesting part about this design is an exponential power engine. Okay, so here this is the rotating drum. Okay, so a drum like this one. Okay, this is the kind of drum he was talking about. And in practical terms, this is a drum I have made. This is a drum. Okay, so you are viewing it from the left or right side. So it looks vertical like this. And at the edge, there are small orifices, holes here. So what happens is you use a 500-watt pump to take the water out and then pump it through the central axis. Okay, so and this wheel starts filling up with water. So when enough water is filled inside, water is going to come out of these small holes. Okay, so and then as the water comes out with force, the wheel starts rotating, and it keeps on increasing, because the more water comes out with more force, more rotation this is going to make. Okay, and beyond certain point, the water getting pushed out towards the edge generates massive amount of centrifugal force that you no longer need any pumping. Okay, it becomes self-running, and if you don't limit the water through a valve, this is going to run away to infinite speed, and it is going to mechanically break the whole structure. Okay, so Kelly has given the entire design. I have also made an attempt to actually make it. The problem is what do you say? The expertise required to actually make it happen is much more than what I was hoping to see. Okay, so here is my design. I mean, we made it in a local workshop. This is the part, the water incoming part, and this is the wheel, the main wheel, and this is the input drive. Okay, so I mean, we connected it and we actually ran it and so on, but I mean, the expertise of the workshop was not sufficient. Yeah, we couldn't really get that to going, and there are successful implementations.
All right, this is the first one with the head pressure.
Okay, so you can see
And I'm using the same type of bushing, but
you can see this water bill running. And even after
as you can see our
power supply, it is maintaining the
it's a
same
little
pressure.
wobbly. That's because I got the PVC plugged into there. I had to make an O-ring to just plug into there so it wouldn't leak. I use that little same bearing for the time being.
Okay, so this is again a really cool implementation of the Donny-Watts generator. Okay, so you can watch the video. I have linked these two videos I have linked, and let me show you the other one. Okay, I don't think the other one is here. Okay, I'll pass. So you can view it over here. Okay, so in summary, you should not really worry about law of conservation of energy. Okay, it is totally irrelevant for practical purposes. Okay, so as I have clearly shown you, free energy devices do exist and they actually work, and there are so many successful implementations out there. Okay, especially the Milkovic pendulum-based devices and designs, both just swinging as well as rotating. Then Skinner's shifting weight design, okay, and Donny Watt's centrifugal force-based designs. So these are really awesome designs which anyone can easily make. I mean, with a fair amount of hardware knowledge and mechanical skills. Okay, and the incoming energy crisis which is going on, I mean, they already started in Europe. I'm sure they are going to push it on every other nation. Um, so, I mean, help yourself. Okay, so you can very easily make these devices and, I mean, go energy grid free. You don't have to depend on the central authority to build one. I mean, for your electricity needs. Okay, if you cannot do it, get together with friends and family and make a community-based effort to make these devices. Okay, so my effort to make these devices, especially Milkovich pendulum-based devices, it is continuing. I'm making some progress. I'll update you later on when things come to fruition. All right, so that's it for today, and thank you for listening.